Hey guys, welcome to the video. I believe we're live now, so we can easily start. So for today, we have to talk about Elasticsearch with .NET, and I have added some additional things besides Elasticsearch from the Elastic company, which is pretty much the Elk Stack, or in other words, Elasticsearch, Logstash, and Kibana. I'm going to talk about this stack, I'm going to talk about why we may decide to use it, and I'm going to make an intro of all these tools because they work together and they work quite, they're quite helpful in certain situations. So today we're going to cover mostly Elasticsearch, in the .NET world, how to wire everything together by using the best practices possible. But before I begin, I would like to apologize because this live class had to be done back in February and currently it's the end of March. But last month was kind of crazy for me, so I'm really sorry about delaying this class that much. Uh, for some reason, I got really sick. I was in bed for like 10 days, and it was quite strange because usually my body and my metabolism are quite healthy, and when everyone around me are sick or ill from common cold or flu, it's nothing for me. I don't catch anything. Normally, I try to eat healthy, try to move a lot, I try to do a lot of sports, but for some reason, this time it was very heavy, and I have a feeling that it was the coronavirus. But I did 3 tests and they all came out negative. So it was kind of strange. I was not able to work for 10 days, and in my main job, everything got delayed for this, and it was crazy, and I had to finish everything. So, yeah, this is why, mainly this is why this class was so delayed, and I'm really sorry for that. For this reason, this week and the next week, we will have 4 live classes in total, so I believe I will be able to compensate for delaying this one. Uh, that's the main reason, and unfortunately, then my internet got kind of hacky, and I was not able to stream. But nevertheless, everything is good when it ends good, so it ends well. So let's do this now. Yeah, so I hope you can forgive me about this delay because I was really worried about it. And as you will see, this topic waits for you for since the beginning of March. But yeah, okay. So just to say for everyone who didn't read their personal messages, tomorrow we're going to talk about essential microservices concepts. I've prepared a working, ready to be used and ready to be deployed microservices app for the demo. So we have a lot of things to cover. Unfortunately, it won't be possible for me to show all the main concepts and the code for them in just 2 to 3 hours. So I've decided to split the class in two. So part one will be tomorrow and part two will be next week. If for some reason, because I tend to talk and describe a lot of things, if for some reason these 2 days are not enough, we're going to have a third one. Of course, there's no additional charge because I just want to make sure that everything is covered in these important topics. Good. So tomorrow we are going to have another class, and next week we are going to have 2 more classes, and I'm going to post the dates soon by the end of the week. Good. So now let's get back to Elasticsearch with .NET. It's very important to understand what are the Elasticsearch Essentials before we start using it with .NET in general. I've already created a video about Elasticsearch Essentials, so you may have watched that. And if you haven't, I strongly advise you do, because I explained the most common terms, most common things, most common types, document indexes. I explain the most commonly used terminology in Elasticsearch and what's the difference between Elasticsearch and other non-relational database. I'm going to make a summary of all of that in today's class, but it's going to be like 2 to 5 minutes, something like that. So if you haven't watched the essentials part, please do. Good. So let's first start with the main usages of Elasticsearch. The main usages of Elasticsearch are logging and log analysis, combining public data. If you have multiple web APIs, for example, or if you have multiple data sources, you can use Elasticsearch to combine all these data sources into a single data store. You can do you can store different kinds of metrics. For example, which user clicked on the purchase button, which user did not click it, which user added a product in the cart but did not purchase anything. You can use such data in Elasticsearch. You can use Elasticsearch for full text search, which is actually the main feature of Elasticsearch. This is the main topic around Elasticsearch, and this is the most important thing around Elasticsearch. All the other usages derive from the full text search. Finally, if you decide to add a tool called Kibana, which I'm going to show later during the class, you will be able to easily add some data visualizations on your app. So these are the main usages of Elasticsearch. And if you understand how to use a full text search, the full text search functionality in your code, and if you understand how to use the logging and log analysis for with Elasticsearch, then I believe you will understand the core concepts of the whole Elasticsearch and Friends stack. These two are the most important parts, because if you understand how to use logging, you can easily then use the same stack for the other usages. For example, you can easily convert the logging for matrix. It won't be that difficult for you to convert the usage, because the main concepts are the same. You have lots of incoming data, because let's consider what we have with logging. When we have logging, we usually, if our app is big enough, we have a lot of log entries, a huge amount. Consider this, because usually in every application disasters happen. Some errors are thrown, some exceptions occur here and there, some partial failures, for example, in some of our services may not be working or maybe partially working. So for some users, the app is working correctly and it's showing it's perfect in terms of usability, but for other users, something is buggy, something is not quite right. And for this reason, we need to establish logging. I believe that everybody who has developed a single app in their life understands the benefits of logging, because it's a common case that something works on production, or something doesn't work on production, but it works locally on our machine. And if the business says, hey, you have a bug and I cannot reproduce it locally, I need to analyze the production logs. And if I don't have detailed production logs, I may not be able to replicate the issue. Of course, if I don't have production logs, then it will be required, it will be a mandatory task for me to create and to add these logs. That will be super important, and that's essentially if I don't have logs, I need to add them as soon as possible. Okay, so let's say that we have a perfectly fine walk mechanism in our website. And if we have lots of users, let's say thousands of users per hour, and each user makes hundreds of requests each hour. So that means that for each request, we need to log everything we have. We need to log the user data, we need to log the request endpoint, we need to log any event that happens, we need to log any business logic that's important, we need to log any exception that happens, and so on and so on. So basically, we have a lot of things to log. So if you have thousands of users, you will have hundreds of thousands of log entries, and that's quite a lot of data. So we need to have a data store which allows very fast and efficient insert. Very fast and efficient insert means that most probably we will need to use a non-relational database, but that's not always the case. Let's continue with our requirement analysis. Good, so we have a lot of inserts and we have rare reads. How often do you read log data and how often do you write to it? You write every second hundreds of entries. So you write a lot, but you read only when a problem occurs. Or, for example, you read every hour to check whether an error occurs. You may read every 1 minute for something like a health check or different kinds of scenarios, but you read quite rarely compared to how often do you insert data. And that's the important part here. So we have a lot of inserts and not that much reads. Typically, non-relational databases are great for these scenarios because non-relational databases are great for inserting data, they are great for reading data, they are not that great for deleting or updating data. They're okay, but that's not their strength. So for our logging purposes, we may decide to use MongoDB, for example, because MongoDB is certainly great in terms of storing lots of data and in terms of querying lots of data. So MongoDB will be quite fine. The problem here is that usually logs contain a lot of text. For example, if you have an exception message, you have huge stack trace, a lot of text, a lot of extra information. You have mostly huge texts which you will need to index. So MongoDB doesn't index the text by default. You need to have something else configured on the database. So for this reason, because most probably the usage case for reading and analyzing the logs is by searching for some keyword in the text. Let's say that some user is reporting she's receiving invalid operation exception with specific message. Your credit card was declined. And she explains to us that this credit card works perfectly fine and there are no issues on other sides. So we have invalid operation exception, we have your credit card was declined text, and we have the username of the user. So we need to be able to fastly search for these three terms. We need to find easily invalid operation exceptions. We need to find easily your credit card was declined, the error message, and we need to decline easily. We need to find easily the username. So with MongoDB that would be a problem, but here comes Elasticsearch, because Elasticsearch is also a non-relational database, but it's different from 1 minute. Need to. For some reason, these headphones, they're great in terms of sound quality, in terms of microphone, they're great, but for some reason, they turn off every 20 minutes if no music or no sound comes from the speakers. Even though the microphone is working and I'm currently speaking, for some reason they just turn off and it's quite annoying. So for that, because of that, I need to put some music on a very low volume. Super strange. Okay, so let's come back to our Elasticsearch usage. So we have logging, and mm, Elasticsearch is better compared to other non-relational databases because it indexes texts. And what is contained in log entries? Texts. And for this reason, Elasticsearch is better, but we have more problems to solve because logging usually comes from different sources. For example, the database may output some logs, we may have a lot of microservices which may output some logs. We may have some message queues that output some logs. We may have a Redis database which outputs a log, and we may have different log sources, and all of these sources may have different schemas. So in order for us to add everything in Elasticsearch, we will need something to get all of that data from all the different sources, combine them to a single schema. So we need to merge all that data into a single schema and then store it on Elasticsearch. This way, all the logs from our system will be in a single source of truth. So we will need something additionally to get the data before putting it in the Elasticsearch data store. And finally, we will need to have something that will help us visualize all the logs and will help us create some charts, create some create easy searches, and create different types of visualizations. So Elasticsearch on its own will not be enough for solving the logging problem. And if we consider combining public data or the matrix usage, these are similar in terms of logging and log analysis, because combining different log sources is exactly combining public data, is the same business case, but it's not about logs, it may be about something else. Then we have metrics. Metrics is again a lot of data inserted from a lot of places, which needs to be merged and converted to a single schema, and with this data needs to be easily searchable when we need to analyze something. So essentially it's the same thing, only the data type is different. We don't store logging, we store some matrix. Good, so if we understand how these tools work together to log and allow us to analyze the logs, we will understand everything else related to Elasticsearch. Of course, there are some situations in which we may decide to use Elasticsearch as a search engine directly in our application, and I have a demo for that. I'm going to show that, how to incorporate it. But it's important to understand these two use cases: full text search and logging. Oh, everything else is pretty much building around that. So let's start with logging and log analytics. Logging and log analytics is easily done by the so-called Elk Stack. Elk Stack is super popular stack for logging and for storing lots of data which needs to be visualized later, but don't need to be visualized super often. So the Elk Stack contains Elasticsearch, contains Logstash, and contains Kibana. And I'm going to explain all of these. I'm going to show you how they work. I'm going to show you how to configure them to work together. Let's say that it's not very difficult to get started with these tools, but it's a bit difficult to understand everything which is in the documentation. Because the last time I used the Elk Stack, it was a few versions ago, and they were a little bit different. I believe that now they're easier to install and use, but still you need to read here and there in the documentation, and most online tutorials are unfortunately outdated, but nevertheless the main idea, I'm going to show you the main idea. So we have the Elk Stack. I'm going to explain how everything works with the Elk Stack. First things first, we have the Logstash. The Logstash is a tool for combining data. Logstash can easily read data from multiple sources. Let's create something like this. Let's say that we have a microservice here, we have a Redis cache here, and we have a database here. All these three applications create a different log. Let's say that the Redis logs to a file, the database logs to a file, and the service, the actual application, doesn't log to a file, but instead wants to log through HTTP. So wants to send the logs through the internet, and that's it. So, of course, the end goal is to have Elasticsearch here as a data store. So we want to have a data store here, which will be which will store all the logs from these three applications. The problem is that the service application uses HTTP and the other two uses file, which is not convenient. We need to have something here to read the data, parse it in a single schema, a single format, and store it in an Elasticsearch index. If you don't remember what an index is a named entity in Elasticsearch in which we can store different documents. All these documents are indexed by default, and we can easily say, I want to search in this index for for example, for the word cat. So in a real-life scenario, we will create different indexes for different purposes. For example, we may have a logs index, we may have a cars index, we may have users index, and so on. It depends on what we want to search by text later in our app. But for now, let's say that we need a tool to convert all these inputs, all these logs, from their different schemas, because the app will log HTTP requests. The Redis cache will log saves and retrievals. The database will log all transactions. So these have different schemas. And we can either create a single app with our own code to read from these data sources and convert the data before storing it into Elasticsearch, or we can use the Logstash tool, which is pretty much doing that. The Logstash tool is reading everything from different sources. It knows how to filter and mutate the data. So we can easily say, get only this field from here, get this field from here and convert it to something else, and get these two fields from here. So Logstash can be configured to filter the entries. Let's say that we don't want to store warnings. We only want to store critical errors in our app. That's not a good idea, but let's say the requirements are something like this. So we can easily filter by saying I want to filter by the type of the event. If it's an error, store it, otherwise delete it. We will be able to mutate the data from the different sources so that the end document will have a single schema. So pretty much Logstash gets data from multiple sources, filters it, mutates it, and stores it to Elasticsearch. Or of course we can say that we want to store it on something else. For example, we want to store it on another database, or we want to store it in a file, or we may want to store it in a message queue. There are lots of plugins for the Elk Stack, so it's very easy to make it work for your scenario. Finally, when we configure the Logstash tool to fetch different data, we can add the so-called Kibana tool. Kibana gives us visualization from the Elasticsearch data store. So if we want to visualize the data to search fast and convenient through the Elasticsearch data store, we would most probably want to use Kibana, because the Elasticsearch itself doesn't have a front-end UI, so it won't be convenient to search for different logs or other things we want to search. So Kibana will be used for our dashboard or visualization. Good. This is the most commonly used approach, but this does not scale well enough, because in some scenarios we may have huge enterprise projects. For example, let's say that we have a lot of applications here, 6 of them, each of them has a database. I'm not going to draw everything, but we have a lot of things to consider, and we have a lot of services, a lot of tools, it's quite a huge app. So the logging mechanism cannot be that simple. So we can include a fourth product here. It's called Beats. The Beats product is, like the name suggests, fetches data at a certain interval. So it's easier to not overwhelm the Logstash server. So by using Beats, we can easily fetch only the amount of data we can handle at certain time. So it will be easier, and it will be more convenient for our servers, because they won't be over polluted with data. That's the whole idea behind Beats. So we can easily say, hey Beats, I want you to read data from this file here. I want you to read data from HTTP here. I want you to read data from here, and so on and so on. So the easiest way to do everything is to make every single service store a log file locally, and then Beats will come to the log file and collect it. And Beats will be able to send that to Logstash. Of course, we may have multiple Logstash instances. We may decide to put a message queue in front of Beats and Logstash. We may put a message queue after Logstash because it sends too much data to Elasticsearch. We may improve the infrastructure as we see fit, but every scenario is different. For your application, maybe the the example I showed earlier only with Elasticsearch, Logstash, and Kibana, it may be sufficient. It may be completely enough, and it may work flawlessly. Of course, if you happen to see that you have some different problems, for example, if you see that the Elasticsearch hard drives are getting filled quite fast, you may decide to add multiple shards of Elasticsearch. You have a lot of options. This is why I won't be able to cover all of them, but keep in mind that you can easily scale the logging mechanism if you need by adding message queues before or after the Logstash. You can easily add the beads tool to save to make sure that Logstash receives the data in chunks and not all at once, and so on. So pretty much we need the bare minimum is that we need the Elk Stack. We need someone to store the data. We need someone to collect the data and produce a single format of that data, and we need to visualize the data some way. Good, and within the .NET world, we need a tool to use in our C# code. Serialog is a good enough tool which you can use, and I'm going to show you how to easily configure it. Of course, Serialog contains a lot more features than what I'm going to show you, but nevertheless, it's important to understand that it's just a tool. It's not important for the Elk Stack, and you can easily write your own things. Of course, that will need support and maintenance, but you can easily write your own Serialog tool, or you can easily use another tool. It's not required, but it's one of the most famous logger tools for .NET, so this is why I decided to include it. What we need to do is we need to install all of these tools. Serialog is a typical NuGet package, so I believe you know how to install that, but all the others need to be installed manually. You can use a Docker container. All of these tools have Docker containers. So if I go, I can say Docker Elasticsearch, and we will find how to install Elasticsearch through Docker. Yeah, it has images. Of course, I don't want to show everything to be that easy, because by using a Docker container, everything comes a little bit easier. So let's analyze and see the manual installation, the manual thing we need to do, and then we can start using Docker containers for the Elk Stack. But in my opinion, if you are not using Docker containers at all in your company, then you don't need to use Elasticsearch with Docker containers. Good. So installing Elasticsearch is pretty much straightforward. If we go to elastic.co, elastic.co has a lot of products, but you will find Elasticsearch, Kibana, you will find Logstash, and you will see a lot of things and everything here in the Elk Stack. It's completely free. It's completely free. The problem is that if you want to use it for something more, for example, if you don't want to host it by yourself, if you want to use a cloud, and if you want to have some advanced features, you need to pay for the Elastic Cloud. But if you want to download and use the tools locally or on your own server, they are free. They're completely free. So because it's a little bit tricky to find all the pages in the website, you can easily use Google search, or just click here. It doesn't matter. So, okay, we click download. We follow the instructions. We decide whether we want to use Linux, Windows, Mac. There are different instructions for the different operational systems. Of course, I'm not going to download or read or follow all these tutorials. Here you can do that on your own. My idea about my classes is to explain you the concepts, because everybody can read uh, online. Everybody can read documentation, but most of the time the documentation has a lot of information. It's difficult to understand what exactly you want to do. It's difficult to start from somewhere. So this is my idea of the class, to explain you the concepts, to explain you how they work together, to show you some code, and from there on you will be able to find solutions on your own. Good. So with the what you need to do is just download of course this is for the Windows version, but Linux is not that different. You need to download 3 zip files. You need to download the 3 tools separately. You need to download Elasticsearch, Kibana, Logstash. Of course, if you want to test beats, you need to download beats, but for this demo I'm not going to use it, because I'm going to use HTTP codes to store in Logstash. So we need to download some zip files, and pretty much that's it. Each folder has a bin folder which allows you to start the specific service. For example, if you want to start Kibana, you need to go to the folder in which you installed or extracted, because there's no installer, there's just a zip file. You need to extract the tool and go to the bin folder. You need to do the same thing for all the 3 tools with 3 different command line interfaces, and you need to start them. Logstash needs to have a configuration, because you need to configure Logstash how to get the data and how to convert the data and how to store the data, because by default Logstash doesn't know where to store the data. It doesn't know whether you're going to use Elasticsearch or something else. Also, Logstash doesn't know by default whether you're going to use files, or for example HTTP, or for example some JSON things or XML things. You need to configure Logstash to tell it how you are going to provide the logs or the data itself, and how you are going to store the data after Logstash filters and mutates it. Good, so Logstash cannot be started for now, but never mind that. We're going to start first Elasticsearch. So what you need to do is you need to go to your Elasticsearch folder, then bin, and then what you need to do is just run elasticsearch.bat. It's pretty straightforward. For Logstash, I'm going to start it in a minute. And then we have Kibana. You need to do exactly the same thing. You need to go to Kibana, the bin folder, and then run kibana.bat. Keep in mind that Kibana starts for a minute or two, so we need to wait a bit. Don't worry if you receive some warnings or errors. That's because we don't configure any users and authentication, but that can be easily done if you want to protect your data. If your data is not on a protected server, you can easily add authentication. Or if you want to access Kibana publicly, you need to add a username or a password. If you only access it in your internal company network, then maybe a username and password won't be needed. Nevertheless, that's just a matter of additional configuration. We can see that Elasticsearch should be working correctly. By default, Elasticsearch is working on on this port. So if you go to localhost 9200 or 9200, you will see that Elasticsearch is working. So Elasticsearch, if we go to this address, localhost 9200, we will see that Elasticsearch is working with a single node, with some name, we have some version, and we have, for search, their tagline. So this means that Elasticsearch is working and is currently able to receive or provide data. Good. Kibana started to. We have some warnings. We have some. Like I said, we have some warnings, but the server is running here on this localhost 5601. 5601. So if I go to localhost 5601, I will see that Kibana is starting. This is Kibana. Currently, it shouldn't have anything unless I forgot to delete something. We're going to take a look at some of the tools here. One of the most usable tools is the DevTools here. So if you go to the Kibana menu and then go to DevTools, you will see a console with which you will be able to create queries against Elasticsearch. For example, if I decide to check what kind of indexes I have, I will see that I have these indexes. I have car rental logs, car add full text search model index, some other private things. The car rental and car add full text search blah 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 are from my demo code, so we're going to take a look at it during the class. Good, so this is Kibana. Of course, you may be familiar with it because I showed this console in the Elasticsearch Essentials video, but nevertheless, I have to explain everything again. Good, so let's go to the home page. We are going to take a look at Kibana a little bit later. And now how to configure Logstash, because in order to add something to Elasticsearch automatically, we need to configure Logstash. We need to specify how the log data is received. We need to specify how the log data is converted and so on. So all of these tools, the Elasticsearch tool, all of these tools have config files. If we go here, we can see that we have elasticsearch.yaml config. Of course, these configs have some default configuration. For example, I just specified my cluster name and node name. So I specified how my Elasticsearch instance will be called, which is pretty much not that super important, but of course it's a good idea to name your cluster so that it will be recognizable. You can easily specify the network host. We didn't specify any network host, so we're using localhost, but otherwise, if you have a specific IP, you need to specify it here. You can specify a custom port, default one. We already saw it, that it's 9200 and so on. So all these tools have some configurations. If we go to Kibana, we will see that Kibana also have some configurations here, and you can easily read what all these configurations mean. For example, if you want to configure with a username and password, we can add something here. We can add certificates if you want to enable SSL and so on and so on. So if you decide to configure these tools for more public use, you will need to change the local host, you may need to change the IP and so on and so on. So all these tools have configuration, which if I have to be honest, these configurations work perfectly with their default options. For production ready scenarios, we may need to specify the IPs, and eventually we may need to add some authentication because we may want to protect our logs. But if the servers are not accessible outside of our network, of our internal network, it may not be required. So it depends. Good. Then we need to configure Logstash. I have linked a pretty much detailed lesson about Logstash filters if you want to add some filters, but I'm going to provide you some examples because there is no need to specify all the different filters. You have a lot of things you can do. For example, you can say, give me only entries from the logs which are 1 hour old, or give me only entries from the logs which are type error, give me entries from the log which store in the database, and so on. You can filter by a lot of things, and if you cannot find what you want, there are a lot of plugins for Logstash. So most probably your scenario is already covered by either the built-in filters or some of the plugins. Good. So this is the typical diagram we need to use. I already showed that, but usually you have multiple services. We have Serialog exceptions. Serilock sends all of these to Logstash. Logstash parses the different messages the way we specify it and transform them and stores them into Elasticsearch. Then we use Kibana to visualize all of that. So here is the Logstash configuration in its most basic form. I've pasted it here, but I'm going to show my configuration directly. So here it is. It's in the config.txt file. Of course, it may be config.conf file or whatever. So we can see that I've added some configurations here about how to get the data. First, we need to specify how to get the data in Logstash. And since I know that my applications are going to use HTTP and are going to send the data through HTTP, I need to specify how. I say, well, I want Logstash to work on localhost. I want to have it working on this port, and the default format will be JSON. Why JSON? Because I know that Serialog will use JSON to send data. So this is specifically created for my Serialog configuration. Of course, if I have multiple sources, I can easily specify, for example, some file here. And I can say I want to have a file, its path is whatever, and so on. And Logstash will get both sources. It will get HTTP and file. Good, so I specify the host, I specify the port, and I specify the codec. This is the first part. I need to specify the input, how my logs are going to enter Logstash. Good. The last thing, because I'm going to talk about filters in a minute, the last thing is I want to output the data somewhere. So the output currently is two different outputs. The first one, actually the second one, is the console. So every single event will be logged in the console where Logstash is running. And the second thing is I need to provide Elasticsearch here because I want to store all the data in Elasticsearch. Good. Where is Elasticsearch on my machine? Well, it's on localhost 9200 because that's the Elasticsearch configuration. How I would like to name the index? Well, it will be car rental -logs because my application is actually a car rental system. And finally, we have a document type, and we say I want the document type to be log. This is just for developer purposes. You can write whatever you like. You can write your name here. It doesn't matter. It will just say that the document type in Elasticsearch is its name is log. Good. So we need to have an input, and we can provide multiple inputs here. Logstash even provides multiple pipelines, because here I provide just a single configuration. But if you want to split your configuration in multiple files, you can use the so-called pipelines. I'm mentioning them because you may decide to read about them. But the pipelines allow you to have multiple sources from multiple configuration files with different configurations. And currently I'm using, let's say that I'm just using a single pipeline because I want to have the HTTP the HTTP call to Logstash. This will be more than enough for my case. If I want, I can easily add other things, or I can add the so-called pipelines. If you want, you can read about the pipelines. Then I have an output which provides some information about where I want to output my data, the console and Elasticsearch, and these are the Elasticsearch variables and Elasticsearch connections, so to say. Then we have a filter. This is not required, but we can add a filter to our entries. And we have a lot of different filters. If you go to Logstash filters, filter plugins, let's check here. You can see that you have a lot of filters. As you can see, I'm using mutate. Mutate means that I want to change the data before I store it, but you can have different filters here. It depends on what is useful for your case. For example, grok is super useful filter because it parses unstructured event data into fields. So with the grok filter, you can easily parse your data. Yeah, there are a lot of filters, and there are third-party filters. So yeah, there are a lot of options here. Let me check the internet because I can see that it's having a problem again. I think it was only for a second, but let me check. Yep. It should be fine now. So it should be fine now. Yep, I believe it's fine now. Let me check it again. Otherwise, I will go to the backup internet. Yeah, it should be completely fine. So let's explain the filters again. We have a lot of filters. The configuration file consists pretty much of input, how we get the data, output, how we store the data and where to store the data, and filter, what to do with the data before sending it to the output. And we have different various filters. Like I said here, we have a lot of filters. We can easily search Logstash Logstash filters examples, and we can see a lot of filters plugins here. Good. The internet seems okay. Yeah, and like I see, well, that's not less than that. Well, okay. It looks fine now. Good. So what are the filters here? Well, I know that Serialog sends the data in an events array, so I'm using a split filter. I want to split the events array in multiple events. So Serialog will send some data in an array format and I want to split it. So I'm saying I want to split the field events to a separate field target. And then I said mutate the data, remove fields, remove the events because I already split them, and remove the headers. So uh, these are the things I'm doing here, and I'm doing them just as an example. It's not required. You can do whatever you like, and it's not required. It doesn't matter. But I'm just specifying some filters here so that you can see that you can do different things with the data. And you have a lot of filters available, and you can do a lot of things with uh, them. You can parse the data, you can mutate the data, you can delete some fields, you can add fields, you can do whatever you think it will be useful. And now let's start Logstash. To start Logstash, we need to say run Logstash bat, but use a config. And the config is provided by using -f and a path to the config text file, which I already showed you. So let's run Logstash and wait for it. Since 1 hour passed, I'm going to start a small break of 5 to 10 minutes, and after the break Logstash will be started. Good, I can see that the internet is now fine. Fortunately, for some reason we don't have now the speed should be fine. Yeah, for some reason the internet is having troubles, and I even have a backup internet and I use it too, but I guess technical issues occur from time to time. Nevertheless, okay, I showed you my Logstash configuration. Here I have a filters example, which again, this is not required, but I'm just showing it that because you need to know that there are multiple filters and you can use them. Good, so let's do a small break and we're going to continue after it, 5 to 10 minutes. And Okay guys, let's start and let's continue. I can see that there were no other internet problems, so we can continue with our lesson. Good, so far I explained Elasticsearch, Logstash and Kibana in terms of how to install them, what they are, how they communicate with each other, and now let's continue with adding all these things to .NET and how to do it. So first things first, we need Serialog, and different Serialog packages exist depending on what we want to do. So first we want to install Serialog.asp.NET Core, because if we're using an ASP.NET Core application, this will be easier for integration. We need to add Serialog settings configuration for configuring Serialog, and then we can add different things for how to send logs. Uh, in terms of Serialog terms, they're called sinks, and for each different type of Serialog Serialog type of communication, there is a different sync. For example, we can say we have an asynchronous sync if we want everything to happen asynchronously, and that's the preferred approach in an ASP.NET Core application. We may have an HTTP sync, a file sync, and so on. So if we want to read logs or to send logs to a file, we can use the syncs file package. If we want to send logs through HTTP, we can use the syncs HTTP package, and so on and so on. So we need to install these packages. To install these packages, I have this project here. This project will be shown tomorrow too. It is a microservices app, a fully working microservices app. And currently we have a single service, dealers. It's a car rental system in which dealers can register and can publish cars for renting. That's the business behind the system. And so far we have some controllers. For example, we have controllers for the dealers, for getting a dealer, for creating a dealer, for editing a dealer, and so on. And we have a car ads controller, which allows us to search, to get details of car ads, to create a car ad, and so on and so on. Good. Then we want to add logging to this application. The whole application actually can be run with Docker Compose, because we have a lot of things going on. So we can go to Docker Compose and write up. You need to have Docker Desktop running if you want to run that locally. But after running Docker Compose up, we're going to see a lot of failures until the app is run correctly. Let me restart it. Because it's a lot of noise here, I prefer to start it by using Docker Compose app-d. Because it's too much noise, every single service logs to the console, and it's better to actually log to Logstash, but we have only created a single service to log to Logstash. We're going to see how the dealer service is logging to Logstash and is using Elasticsearch. That's the whole idea of the demo. And of course, if you want to add the same thing to the other services, because we have service for statistics, we have service for authenticated users, for notifications with SignalR, and we have a watchdog and so on. If you want to add different services to Logstash, then we need to add the same code which is already provided in the dealers. I'm going to provide the link to the code, so there is no problem here. Okay, good. So we may have on localhost, we should have a working app. Home, create carat, we can create a carat. Yeah, okay, it should be working correctly. We can see that the Logstash window, because this is the Logstash window, started showing some log entries. This is because the dealer's microservice is configured to send data to Logstash. So we can see that it's working, and we can see that the requests I did earlier are now showing here. So we can see that currently we have a health check running, we have logs. So we can see that our app is successfully logging to Logstash. All of these should be going to Elasticsearch too. Okay, so this is if you want to start the app, to play with it, to work with it, to check something out, and so on. So I just decided to show you how to run the app. Of course, like I said, you need to have Docker Desktop installed. I have it, and it's up and running currently, but nevertheless, we saw that the Logstash logging is working correctly, and we can also do something like this. Okay, let's run it again. We have localhost 5200 car ads. I believe. Let me check the Docker Compose file. Dealers are on, yeah, it's a different port. So let's go to here. There are. So we have all the carats. We can see that the endpoint is working correctly. We can see that it's returning all the carats in the system. Yeah, okay. So the app is running correctly. We will be able to see here that we have logging is working correctly, so our configuration is fine. And now we need to see how to do that from the code, how to configure the app to use Logstash. Let me just Docker Compose down. Good, so first things first, how to wire the logging service, how to do the logging. Well, to do the logging, we need to make sure that our app has logging even before the startup, because our app may fail during startup, and if the app failed during startup, we won't be able to analyze the logs. So our logs need to start before even the configure services method is called. So we need to do something in terms of logging even earlier. The only thing earlier that we can control is in the program file. The program file allows us to add different things. So for now, we can see that the default program file, for example, if I go to the statistics service, I will see that we have something like this. The default ASP.NET Core configuration, host, create default builder, this and this. So what I like to do is I like to extract a host class which is going to be used among all the microservices here. And the host class is car_rental_host.start. And here I configure the logging. How to do that? First, we need to find the log connection. And the log connection comes from an environment variable because locally this will be localhost. On a production server, it will be something else. So yeah, log connection is coming from the log connection environment variable. If I go here to the dealer's microservice, I will see that I have an environment variable called log connection. And this is pointing to the port of Logstash. Why it doesn't show localhost here? Why this is not localhost? It's because when I run an app inside Docker and I want to access something on the host machine, I cannot use localhost inside the Docker because localhost is inside the Docker. So I need to tell Docker to use the local host of the host machine. And this is the string I need to use, host.docker.internal. Of course, if you run Elasticsearch on another Docker host, you need to write the correct host here. So this is just the URL of the log connection. And you can see that I even provide the Elasticsearch connection, which is again localhost 9200, which is the port we showed earlier. Good. So the whole idea is that I need to provide the connection to Logstash. Connection to Logstash is configured in the Logstash config file, which is here, localhost 28080, and we can see here that we use localhost 28080. So pretty much that's the way. And again, I'm not writing localhost here because I'm running the app inside a Docker container. So this is important for the Docker container accessing the localhost. If you're not familiar with Docker, let me know and I'm going to create tutorials about it. I'm going to create advanced fundamentals course on Docker, but also what I'm going to do is publish a video about using Docker with microservices. It's essentially this, how to create the file here and what to do in it. That's the whole idea. Okay, good. So I've added an environment variable log connection. And configuring Serialog is quite easy actually. What we need to do is we need to say I want to have a new logger configuration. Log.logger equals new logger configuration. Then we say enrich from log context. This essentially means get everything you can from the default ASP.NET Core logging. And I'm saying write to where I want to write. And I'm saying write to HTTP. If you install the package for file, we can see that we have the file here. If we install that, you can easily log to file. But here I said write to the log connection, which is essentially write to Logstash, send the data to Logstash. And because Serilock sends the data by default in JSON, this is why I in Logstash specified that the data comes in JSON format. Otherwise it won't work. And then what I can do is I can say use Serilock. This will essentially override the default behavior of the ASP.NET Core logger, and it will use Serilock configuration. So by specifying use Serilock here, the logger is going to from now on the iLogger interface, the familiar interface from ASP.NET Core is going to send data to Logstash. So this is essentially super useful and super easy to configure because pretty much that's it. We just need to configure this and provide use Serialog, and every time we decide to use the iLogger interface, which comes from Microsoft, I can easily use it and it will send the data to Logstash. So that's pretty much it. It's a little bit weird to configure the logger because it's not in the startup class, and the reason for that is because we want to create the logger as early as possible, like here, because creating the logger as early as possible allows us to catch exceptions in the code here. So if we have an exception in the web host, for example, this method, if it throws an error, the logger will catch the exception. And this is why we need to configure it first. It allows us to catch every single exception during startup and during the requests and send them to Logstash. But yeah, that's pretty much the important part here. Of course, we can write to file and say I want to write to a file which is some path here and so on. Yeah, dash logs.txt, and then Serialog will start logging everything to this file, and then we can install beats to read the data from the file. But that's not required for an average web application. This is more than enough for an average web application. And if we run a quick search about Serialog in the entire solution, we can see that what we can also do is we can say use Serialog request logging here. This will allows us to override the default request logging. So what we did here in the program start file is that we register Serialog to register Serialog to be the default iLogger interface in our dealers app. So every time somebody uses the iLogger interface, it will use the Serialog one, which is created here instead of the default Microsoft one. And in the startup, we just say we want to log every single request to Serialog, and Serialog will log it to Logstash. So these are the things that we need to do. As you can see, there is nothing else. And if our Logstash configuration is working, we will see that our data is going to be sent to Logstash. Of course, what we need to do is we need to make sure that the data is sent to Elasticsearch. So we can go to the DevTools console and we can say get car rental logs, the index of our logs, underscore search, and we send that, and we can see that we have some log information here. We have some Hangfire servers, we have some other walks from background jobs. We can see that we have some background jobs here and so on. Of course, this just fetches the last 10, but nevertheless, we can see that we have total 1000 elements here. So the logging is working correctly and the logging is fine. We can see that the oldest logs are back on March 8th of March because we wanted to create this class earlier, but yeah, I apologized about that and I hope you forgive me. Good enough. Yeah, pretty much that's the risk when you're working alone, because I do everything by myself. I create the lectures, I prepare the classes, I stream, and if I'm sick, I won't be able to do any of that, and everything gets delayed if I cannot work, and yeah, it's ugly, but yeah, for now I need to work alone. I have some assistants and people who help me, but they are non-technical guys, so yeah, I need to create everything on my own for now. Of course, if somebody is willing to help in one way or another, we may negotiate something, but for now I haven't found such person. Good. So we have a lot of logs here. We can see that the application is using Serialog, which is quite easily configurable, as you can see. We just need to say log every single request. If we want that, we may want to log only specific things in our app. It depends on the scenario. And we need to specify create a logger which needs to send data through HTTP. Otherwise it won't work. So write to HTTP. That's important because currently Logstash works through HTTP. Good. So we can see that Logstash is working, the logging is working, and Elasticsearch receives the data. What to do with Kibana? Let me check whether I missed something from the presentation. Here I entered the Serialog configuration in the program file. Yep, these are completely fine. Good. Which is the message from the app actually. And you can see that we have these two logs. Of course, we can open them, we can analyze everything in a good format. We can see it as a JSON or as a table, but we can see that we have a request to car ads, description car. We can also search for whatever we like. There are a lot of properties here which Serialog sends, so we have a lot of things to car ads. And here are all the car ads logs. We can analyze everything, pretty much everything. All the logs are here. For example, here is the database query which was done for this specific request on 8th of March. Yeah, nevertheless, we have a lot of entries here. As we can see, we run the app, we make some queries, and then the logging are here. And we can easily search and filter them if we like to find something. What we can also do in Kibana is we can visualize data. We have various options to visualize data on Kibana. I'm not going to cover everything because Kibana is a tool which needs a lesson on its own. But nevertheless, I'm going to show you the basic things. From here on, we can use and create different visualizations, different dashboards, whatever you like. So let's go to the lens, and we can create different kinds of charts here. For example, I can create a donut chart, and I can find a property which suits these things. For example, content type. And we can see that our app is run with content type application JSON, and in 51% of the time, and application JSON with a char set in UTF-8 48% of the time. Yeah, so it's very easy to add fields and create different visualizations. For example, I can say I want to have type. Here it is, and I can see the different types which were used. For example, current to system, dealers models, current to system, current search, and so on and so on. So I can easily do different things and different visualizations here. This is text, so this is not something interesting. Yeah, and finally, what I can do, which is useful for logging, is I can create a dashboard. And I can create a dashboard which will have multiple panels with multiple data. For example, I can create a new visualization. Let's say that I want to specify to see how much errors I have in the app. And I can see that most of the log data contains information messages, and I have only 3% errors. Good, so I can save that. I can say something like level donut. And now I have a dashboard. I can add multiple panels with multiple information here, and I can then save the dashboard, for example, home dashboard or main dashboard, something like that. And from now on, every time I want to take a look at the dashboard, I can easily go to main dashboard and see what's going on. I can add different filters here. I can add another panel. I can add another visualization, which is interesting for my app, and so on and so on. So I can easily visualize everything that is happening in my app. For example, I can specify all the error logs in the last 1 hour, and if I see that I don't have any error logs, well, then the app is most probably working perfectly. Yeah, so I can do different things here. I can easily add different panels, different visualizations. It depends on what I actually need. Good. So like I said, Kibana is super powerful tool. And if you want a separate lesson about Kibana, let me know and I will consider creating one. Good. Let's talk a bit about logging best practices. First, don't overlog in your code. Add action filters to reduce the ugliness. Add as many action filters as you can and use them instead of logging in the logic directly. Of course, if you want to log something critical, then do it in the logic. It's completely fine, but try to abstract the logging as much as it's possible. Don't let logging block your application. This is why we installed the async plugin, because we want everything to happen asynchronously and we don't want requests to be blocked. Store logs outside your data center, because if don't put Elasticsearch and database on the same server. Keep them separately. First, because you want to optimize data stores, and second, because if something fails in the data store, you will have the logs on a separate machine. You can set up common searches in Kibana, common dashboards, and alerts for your team. You can easily tell the stack to send you an email or write to, for example, Telegram or a Slack when there is something critical. You need to define what is critical for your system and you can send a message with that. If you have a microservices environment, it's very important to add correlation ID in your requests. Correlation ID is just a header, and make sure that if you have microservice calling another microservice like this, and this calling another microservice, if you have some chain of this correlation ID, then the second one will see that there is already a correlation ID and will not change it. The third one will also not change the correlation ID, and the fourth one will not change the correlation ID too. So only the first microservice that is hit will set the correlation ID, and the next ones will reuse it. The whole idea is that if you have multiple logs from a single request from multiple microservices, you need to have a tool for correlating the data. You need to understand what happens in all the services, so you can easily search by the correlation ID and you will see all the logs from all the microservices. And this is how you will be able to see how the request went step by step. Because if you don't have the correlation ID, it will be difficult for you to match this request here to the specific request here, and you want to check the whole picture as a whole, the whole request as a whole. So this is why you can use correlation ID. If you didn't understand exactly how to use correlation ID, know that if you one day use microservices environment, you need to provide that and you need to research it. I have added more best practices here, but keep in mind that I mentioned most of them already, so check them out if you like. Now, how to add full text search? This is also quite simple, and we need to understand where to add it. I've added the code here, but let me show it in Visual Studio because it's better. So first we need to have a service for Elasticsearch. We need to have a way to add Elasticsearch because let's consider the following scenario. Our app allows us to search for car ads. So we have dealers, car ads. In the car ads controller, we have a search. We have a search endpoint, and the search endpoint allows us to search for manufacturer, category, description, dealer, min price, and so on. The problem is that the description may be quite long and it will be very difficult to use the normal database for this app, which is SQL Server for the description search. Of course, if I have not that much car ads in my system, I don't need to add Elasticsearch. But let's say that I have millions of car ads. I have a huge scale, and searching in a text in SQL Server is less efficient than searching in a text in Elasticsearch. So that's important to analyze and see that this functionality may be easily extracted to Elasticsearch. So what I want to do here is I want to say something like this. If the query from the request has a description field, so if I want to search by a description, I need to first ask Elasticsearch to give me the IDs of the car ads which contain that description, and then I will search in the normal database by this ID. So pretty much the data storage is like this. I have a database containing car ads, containing all the fields here. I will have ID, description, model, and so on. I will have a lot of fields here. And I will have Elasticsearch car ad, which will have only the ID of the car ad here and the description. So every time I want to search something in the description, I will first ask Elasticsearch to give me all the IDs which contain the term in the description. For example, if I search for BMW in the description, I will first search in the Elasticsearch store. I will retrieve some IDs, for example, 10, 12, and 15, and then I'm going to add a where clause to my SQL Server to include only these IDs. That's the flow of the search. So every time somebody creates a car ad, I'm going to add the car ad here, and I'm going to add the description and the ID of the car ad here. So this is how I'm going to store the data in two different places. And then when I want to search, I'm going to search first on Elasticsearch, and then I'm going to search here. Of course, it's a good idea to add defensive mechanism in case of an exception when I want to add the data here, to not add it here, and so on. But nevertheless, this is the main thing we want to do. So here I have a car ads query, and let's see how to integrate Elasticsearch first. First, we want to add some services for the Elasticsearch. I'm going to add them in the common projects because Elasticsearch may be used as a common service in different microservices, so I'm going to add it here. And here I have a full text search service, and I have created a full text search in which I have two methods. The first one is index. I'm giving it a document and it will be indexed by Elasticsearch. And the second one is give me all the documents by a term. So pretty much I will be able to easily index something and return something. Of course, I can provide a field here. So I can easily say search something by the description field by this query, BMW, for example. So this is the iFull text search service. The implementation is quite simple. I just need to install Nest as a NuGet package. I will have an Elastic client, which comes from Nest. This is the interface I'm going to use. And then indexing is quite easy. I'm just saying index document async. And searching is using the default Elasticsearch searching. I'm saying, hey, one moment. Hey, I want to search for this type of document. I want to match this field here. So if you give me description, description. If you give me something else, something else. And I want to query this field for the string you provided here. And return all the documents that were retrieved. That's super convenient and super easy. And this interface can be used throughout our code. Of course, before using it throughout our code, we need to register it in the service collection. So in the service collection, I have a lot of things here at AutoMapper, at health, at messaging for RabbitMQ, at memory database, which is actually Redis, and we have at full text search. This is the method which allows me to create, to add Elasticsearch in a service. So we can see that at full text search has a model. So I'm adding a model on which I want to add indexing. I'm extending a service collection. I provide the configuration from the web project. First, I need to create the index name. The index name is the name of the model. So this is how the index will occur in Elasticsearch. So if I go to the DevTools and if I say give me all indexes here, I will see that I will have carat full text search model underscore index, which is exactly what I create here. The temp model will be carat full text search model underscore index. Then what I do is I have a single Elastic client, a single static Elastic client here, because that's the preferred approach. The documentation of Nest says you need to have a single Elastic client in your application, and this is why I'm creating a single static Elastic client here. And I'm saying if Elastic client is no, then I want to get the Elasticsearch connection environment variable, which is here, Elasticsearch connection, which is localhost 9200. Then I just say I want to have a node for this connection string. I want to have default mapping for the temp model, which I'm providing here, and I want to have it with this index name and create the Elastic client. That's pretty much for creating the client, for creating the connection. Create the connection and create a default index. Then I'm saying create an index for temp model and map all the fields automatically. And I'm adding Elastic client as a service, as a singleton here, and then I'm adding the full text search interface, which is just abstraction on top of the Elastic client. Pretty much that's the most straightforward and super easy to use way to integrate Elasticsearch in a .NET app. You can see that this method is generic, so you can easily use it with multiple models and multiple indexes. It will allow you to create multiple indexes here. Good. Pretty much we are saying map that whenever somebody is searching for this model, automatically map the fields. That's pretty much it. And this is the index name we need to map. Good, and how I'm using this? Well, it's super simple. I'm just saying, hey, I want to add Elasticsearch to this microservice, the dealers one. Go add full text search, pass the configuration, and use this model here, carat full text search model. Like I said earlier, what I want to store is just the description. I want Elasticsearch to index the description, and I want to store the carat ID, because every time I search for something in the description, I want to just get the ID so that I can continue the query in the SQL Server data store. So adding this and adding this thing is then allows me to use the whole Elasticsearch thing. Let me show you how I use it. First, when I create a car, I need to add it both in the SQL Server and in the Elasticsearch. So what I do is I get the create, I find whatever I want to find here, I create the car add, I store it in the database, and then I index it in Elasticsearch. I can use the outbox pattern to make sure that if this fails, the indexing does not, or if the indexing fails, to be retried. The outbox pattern is covered in the lesson Eventual Consistency Done Right. You have that lesson already on Patreon, so you can easily see it. And it's the same pattern here. If you want to have eventual consistency between the SQL Server and the Elasticsearch data store, you can use the same outbox pattern. I show it there in that specific live class. Okay, so we have the full text search, and I just say index, full text search, index this model, get the ID and get the description. Good, and then later if I want to search, because the query searches by multiple things, but I only want to ask Elasticsearch when I have a description. Here is how it's implemented. In the carat listings, I go here in the get listings. Let me go to the thing. Here in the get carats query, in all available, what I can do here is I just have to add the iFull text search. Find all references here, and here in the get carats query I will do the following. First, I'm going to ask for some data which is only available in SQL Server. Here it is. Find the dealer ID, find all the available, whether the carat is hidden. Yeah, some business logic which is coming from the SQL Server. Then I'm searching for category, for example, and if string is null or empty, if the description, if the user is trying to search for something from the description, I'm just extracting from the full text search all the IDs. I'm just saying await from the full text search, make a query for this model, search for description and search for the specific description in the query. And then select all the IDs. So this is pretty much saying if the description in the query from the user is not empty, ask Elasticsearch, extract the IDs which contain that description search term, and you can see that I'm adding a where clause to SQL Server saying, hey, I want to make sure that the query contains the IDs from Elasticsearch. That's the important part here. That's what is important here. So all other things are coming from SQL Server. Manufacturer from SQL Server, minimum price per day, maximum price per day, some paging, and so on and so on. So everything comes from SQL Server, but if the description is part of the query from the user, I ask Elasticsearch for to give me all the car IDs which matches the description. And this allows me to scale searching by the description. So every time I have a lot of text, it's better to add Elasticsearch for searching through the text because it will scale way more easily. And you can use it only for part of your queries, like you see here. Search for the carat IDs which have this description, and then find them in SQL Server. It's super convenient and super scalable. And the search is done very, yep. For some reason the internet stopped for like 5 seconds. Fortunately, it stopped at the end of the lesson. Oof, I have some talks to do, I guess, with these internet providers because that's not professional. Anyway, so if you have any questions, ask them down below in the comments, send me a message. Yep, whatever whatever the way you prefer, just shoot the message and I will try to answer it as soon as possible. And yeah, what we covered a lot. We covered Elasticsearch, Logstash, Kibana, how to make them work together, how to configure them. We covered how to work with them through ASP.NET Core, how to configure Serialog, and how to use full text search. So pretty much I showed you all the main concepts around Elasticsearch, around Logstash, around Kibana, and all the other concepts derived from these two. Good. So thank you guys for being with me during this class. I hope you liked it. I hope you learned new things. I hope you enjoy these live classes, and if you have any suggestions, make sure you ask me, you send me a message, and I will try to improve them as much as I can, because I try to constantly improve all these classes, all these topics. I try to provide as much value as possible. Good. So yeah, if you have any questions, just shoot me a message. If you have any suggestion, do it. If you have any trouble with Elasticsearch or with whatever I'm trying to teach, I'm available and I try to respond as soon as possible. Okay guys, thank you for watching, thank you for being with the class, and I'm going to see you tomorrow. And tomorrow we're going to start working with Microservices Essentials. These Microservices Essentials will show you the crucial concepts in the microservices world, and we're going to show them here in this demo. This is a fully working demo, and I'm going to explain every little bit of it. Good. So that's pretty much for now. Bye, and I'm going to see you tomorrow. Thank you guys.